Welcome to channel for Bible and Math. Today we're going to talk about inverse and inverse functions. What what is that mean by inverse? What does inverse do? And how to find the inverse functions? How to prove that the two functions are inverse each other? How to graph inverse functions against y equal x? And what about the application? And there are types of inverse in algebra. Additive inverse, multiplicative inverse. This is simple. Addition. It's just from 0 to add 4. Then we want to undo uh, by taking minus 4. So make it 0. Meaning that additive inverse of 4 is minus 4. What about the multiplication? Multiplicative inverse, a number and its multiplicative inverse have a product of 1. For the inverse of 4 is 104. So we product 4 times 104 makes 1. So we can say multiplicative inverse of 4 is 104. What about the functions? Functions can have inverses. Functions can have inverses to undo the actions of an original functions. Some functions are inverse of another. If two functions are inverses one another, each function does what the other did. So we're gonna see what does it mean. So first, how to find the inverse function. If the function fx is a set ordered pairs of xy, so 1 to 1. And then the inverse function f of x denoted by f minus 1, that's the inverse, not the reciprocal, not the 1 over f, but this denotes is inverse function of f. It's set of ordered pairs y and x. So it's x and y swap each other uh, and y over x in inverse function. So f and inverse function are reflected image against y equal x. So for example, we have original function x plus 3 over x minus 4, and you want to find out the inverse function. How do we do that? To find the inverse function, replace the variable x and y in original function. We replace x by y and replace y by x, so that here we replace y by x, so and here x plus 3, and we replace x by y plus 3, and denominator y minus 4, and we rearrange it and writing for uh, uh, x times this function y minus 4 equal y plus 3. Then we simplify this and in terms of y. So, and the y equal, so that xy minus 4x minus y equal 4x plus 3. So y take out as a common factor, so y times x minus 1 here equal 4x plus 3, and y function, and in terms of x, it's a numerator part 4x plus 3 divided by x minus 1. So the inverse function of x plus 3 over x minus 4 equal to 4x plus 3 over x minus 1. So this is how you find the inverse function. So now we want to show, since we have two inverse functions each other, and how they can undo one another, and what does it mean. So now we found original function x plus 3 over x minus 4, and the inverse function 4x plus 3 over x minus 1. And we want to take any number 5, so we put the 5 into original function. So 5 plus 3 over 5 minus 4 is what, 8 over 1, so number 8. So we want to put the output 8 of original function into inverse function 8. So then for instead of x, we put 8, and plus 3 over, we put 8 into x, so a minus 1. So then the numerator is 35 and the denominator is 7. So it gives output 5. So 5, we see here 5, this value, originally that number 5 was plugged into original function. And so we can see this is the inverse function, and we get 8 by plugging 5 into the original function. So we are back to the starting point. So this is what the inverse function undo each other. So again, if you put 5 into function f of x, you get 8 as a result. And if you put 8 into inverse function, you get 5 as a result. So you are back where you started. The output of 5 of inverse function tells you that how you get value 8 from the original function f of x. Another example. Now we want to put number 2 into inverse function, and we get the 11. The 11 is the output of inverse function, and now we put it back into the original function. Then the output came out to be 2. So whichever, you change the order from original function to inverse function, from inverse function to original function, you get the, you can do, you get to the starting point. You get back to where you started from the original function f of x. So mathematically, we say this undoing process using composite functions. So we talk about composite functions. So how to know two functions are inverse each other? So this is the definition. We prove by using function composition. If fx and gx are inverse each other, then the composite function, composite, so f of g of x, meaning the the uh, the inside function of f of x, and the g of f of x. So this is composite function. So the f g of x came out to be x, and the g of f of x equal x, same x. So it's the which order you take, the composite function shows always the variable x. So this is the definition. If you put two inverse function f and g, and you take a composite function, and you get x, then that proves that uh, uh, the relationship between two functions f and g completely cancel each other and leaving you with just the original starting value of x. So now uh, in slide number 3, we said we found inverse function f of x. We wanted to find out the inverse function of f of x equal x plus 3 over x minus 4, and we get uh, gx, which is inverse function, came out to be 4x plus 3 over x minus 1. So now we want to take a composite function f of gx first. So now here in original function f of x, the variable x, we plug g of x. So here in numerator x, we plug 4x plus 3 over x minus 1 here, and plus 3. And in the denominator, x minus 4, so we put 4x plus 3 over x minus 1 here, and minus 4. So we simplify this, then f of g of x came out to be x. And then we want to do again for g of f of x. So same, g function is 4x plus 3 over x minus 1. And now here in each x, we plug that uh, f of original function f of x. So here in the numerator in inverse function, we put x plus 3 over x minus 1 here, 4 times x plus 3 over x minus 4, and plus 3. In the denominator, x minus 1 x, we put x plus 3, x minus 4 minus 1. So x minus 4, and the same denominator, so we cancel each other, and we rearrange it, simplify, then we get the x. So we proved that f of g of x came out to be x, and the g of f of x came out to be also x. So we proved that by the definition. We can say f of x and the g of x are inverse function each other. So we can say that the functions f and g are inverse each other. And we want to see the graphical relationship in next slide. So graphical representation of inverse function, because the domain and the range is swapped, so that original function y equal f of x, y, and against, because we swapped x and y, so against f of y equal x, then the inverse function is like this. Its inverse function is reflected image against y equal x line. So like this. And then for the original function, we take f of x, x plus 3 over x minus 1, and we find the inverse function 4x plus 3 over x minus 1. And I graphed two functions by using Desmos, the graph calculator. And now against y equal x, exactly the original function and the inverse function gx is mirror image reflected each other. So this and this, and this and this, and again this side, same. And now we're going to look at applications. What do we do? Why we have to find the inverse function? There are many applications of inverse function. First of all, solving equation. Finding unknown variable in equations often requires applying an inverse to isolate the variable. For example, logarithm functions are used to solve exponential functions. And trigonometry inverse, like arcsine, and to find missing angles and given the side lengths. So in math, there are many applications. What about in financial area? Financial calculations, like if we know the future value of an investment and need to determine the original principal and or calculate the inverse interest rate, so we can uh, use the inverse function. What about unit conversion? How to convert Celsius to Fahrenheit? So you use the inverse function. And in calculus and modeling, finding uh, derivatives is heavily simplified by using inverse trigonometrics or exponential functions, which is highly useful in calculating rates or change of the engineering and physics problems. So this is all about the inverse function. Uh, we can see and how the inverse functions are useful. So this is all I have today. Thank you for watching.